Hello, grade 9 students. Today I will be discussing to you all about the operations on radicals. So let's start by knowing what are the like radicals. So when we say like radicals, the indices and the radicand must be the same. So for example, I have here 4 square root of 2 and 4 square root of 3. So what do you think for this example? Is this the same or like radicals? This is a not or unlike radicals because as we can see our radicand is 2, first radicand is 2 and the second radicand is 3. So even if they have the same numerical coefficient, but since the radicand is not the same, so we can say that this is an unlike radicand. So next, let's have another example. So we have here letter B. We have 3 square root of x and negative 5 square root of x. So what do you think is this? Is this like the radicals or unlike? So this is alike radicals. It is because we have square root of x, you only have to consider the radical expression. So do not worry if your numerical coefficient is not equal, just look for or just consider your radical expression. So we have here square root of x and square root of x. So as you can see, we have here the same radicand x, and also the index is the same. So it is understood that there is an index 2 in this expression. So we have here square root of x and square root of x. So therefore, this is a like radicals. Alright, so next example, we have your square root of 8 and cube root of 8. So based on the sentence or description, they are unlike radicals. It is because we have here the square root, so it means this is, the index of this is 2. So it means they are not equal. So the indexes are not the same. So this is an unlike radical. So always consider the indices and the radicand. So if they have the same radicand just like this one, then they are like radicals. And also if they have the same index or indices, then they are the same radicals. So by knowing this one, we can easily solve our radicals in addition, subtraction, multiplication, and division, because we can just solve this one just like solving algebraic expression. We have to consider the like terms. So let's go to adding and subtracting radicals. So I have a radicals square root of 5 minus 3 square root of 5. So always consider that this one is the numerical coefficient. So always remember that the numerical coefficient is different from index. So for example, I have here 3 square root of 3 square root of 5. And this one. This is 3 square root of 5. This is cube root of 5. So index is different from numerical coefficient beside their radical expression. So they are doing different rule in this expression. So always consider that one. So if you write that one, this kind of expression, you have to emphasize your cube root or index and your numerical coefficient, because it might get you an error way of solving your expression. So let's go back. We have here the subtraction of radicals. So we have here square root of 5 minus 3 square root of 5. So since our radicals is alike radicals, because square root of 5 and square root of 5, they are like. So just like what we did, you can say that these expressions are the like radicals. So it is easy for us to add or subtract this expression. It is because they are like. So what we're going to do is just simply substitute or distribute using the distribution property, just like you are solving algebraic expression. So first that you're going to do is to just copy the square root of 5, both square root of 5. So let's go here. We have here number 1, we have square root of 5 minus 3 square root of 5. So in this expression, it is understood that there is one numerical coefficient in this in the expression. So what we're going to do is just simply combine like terms. So this is equals to 1 minus 3. Where did we get 1? There is n 1 in this expression. There is a numerical coefficient 1. And then just simply copy the square root of 5. They are just the same as, or just copy one of those. So this one, you can just simply 1 minus 2. You are using subtraction because you are using subtraction here because we are this is subtracting. So we have negative 2 square root of 5. So that's it. That is your answer. So this is your final answer for the example number 1. So let's go to another example. We have here 8 square root of x plus 2 square root of x minus x. So what do you think is this expression? Is this alike radicals or not? So from here, what we're going to do is to collect those numerical coefficients. So we have 8, 2, and 1. So it means negative 1. So let's go here. We have example number 2. We have 8 square root of x plus 2 square root of x minus square root of x. So going here, just collect the numerical coefficient because they are alike radicals. So we have here 8 plus 2 minus 1. So 1 is from here negative 1. And then just simply copy the radical expression. So from that, you can just simply perform the operation. 8 plus 2 is equals to 10 minus 1 is equals to 9 square root of x. Then this is your answer. So that's how we're going to solve that one. Next example we have here. Alright, so we have here 2 square root of x minus 3 square root of xy minus 5 square root of x minus square root of y plus 4 square root of xy. So what we're going to do here is to combine like terms. So what are the like terms? So first we have here the square root of x and the square root of x. We have xy and xy. So what we're going to do is just simply combine that one. So we have here, if we're going to combine, so we finally combined our expression. So now let's do the operation. So we have here 2 minus 5 square root of x. Just copy the minus square root of y. And then this 1. So let's just write plus negative 3 plus 4 square root of x y. Alright, so why we use this one plus negative 3? It is because if we're going to multiply positive or plus 2 the negative, it will become negative 3. So plus 4, then x and y, square root of x and y. Alright, so let's subtract negative 2 minus 5 is negative 3 square root of x minus square root of y plus negative 3 plus 4 is equals to 1. So 1 times positive is equals positive x and y. And then next we have negative square root of x minus y is equals to, we can just rewrite this one as square root of yx. So this is now your answer. So do we still have like terms? We don't have any like terms. Then this is your final answer for the expression 2 square root of x minus 3 square root of xy minus 5 square root of x minus square root of y plus 4 square root of x and y. So that's how we're going to solve that one. So let's go to another example. Next, we have here the square root of 75 minus square root of 12 plus 100 square root of 108. So what we're going to do here is just simply factor what are the numbers inside, since they are not an perfect square. They are not a perfect square numbers. So first thing that you're going to do here is to factor. So first that we're going to factor is the 75. So 75 is not a perfect square. So we have here square root of 75. If we're going to factor that one, we will use 25 times 3. So 25 times 3 is equals to 75. Since 25 is a perfect square, we will use 25 times 3 minus 12. So what is the factor of 12 that there is a perfect square? So we can use 4 times 3. So 4 times 3, so we have here 4, square root of 4 times 3. Then we are going to add the another one. So we have 108. We can just simplify that one as 36 times 3. 36 times 3 is equals to 108. So we can use 36 times 3 because 36 is a perfect square. So now what we're going to do is to get the square root of 25, then square root of 3 minus the square root of 4 square root of 3 plus the square root of 36 and square root of 3. So get the square root of 25, that is 5 square root of 3, because of 3 is not a perfect square, so just be it. Square root of 4 is 2, then square root of 3, then what is the square root of 36, which is 6 square root of 3. What have you observed on our simplified fraction or radical expression? We have square root of 3, square root of 3, and square root of 3. Regardless of the numerical coefficient, we have a like radical. So now we can simplify this one first, because we can still combine those numbers, because using distributive property, we have the 3 as their common terms, or let's combine the like terms. So we have 5 minus 2 plus 6, and then we have square root of 3. So now let's simplify this one. Let's do the operation. That's 5 minus 2 is equals to 3. So that's 3 plus 6 square root of 3 is equals to 9 square root of 3. So you might be confused that I'm not using the PEMDAS method. If you have addition and subtraction as your operation in the mathematical sentence, just follow the rule of left to right. So this one, if we can just first add this operation or these terms, you can just write that one in order for you to truly understand kung bakit I just add or do the operation from left to right. So if you're going to add first this expression, you have to include the negative because this expression is as 1. They are negative 2. So if you're going to have negative 2 plus 6 is equals just simply as positive 4. Then 5 plus 4 is equals to 9. So your answer is 9 square root of 3. So this is your final answer. So that's your answer for this expression. Square root of 75 minus square root of 12 plus 108. So what we're going to do is just factor each radicand in order for you to get the like terms or like radicals, and then just simply add the numerical coefficient to get your answer. So that's how we're going to do your or the operations of radicals. So now let's go to let's go to another example wherein we are adding a fraction radicals. So for example, I have here an example. Square root of 5 plus 1 over 5. Square root of 5, then 1 over 5 square root. So now this is a fraction. So if you're going to simplify, a simplified form of radicals cannot be a fraction. Kahit na this is lowest term, pero hindi pa rin siya simplified because of the radical sign. So what we're going to do is to eradicate this one. So since if you can rewrite that one, square root of 5 plus square root of 1 and square root of 5. So if there is a fraction as your radicand, you have to get first the square root of your numerator and your square root of your denominator. So just like this one. So if we get the square root of that, we can just simply get first what is, or let's rationalize first the square root of 5. It is because you cannot add with the radical sign below. So do not mind this one. Just simply multiply simply multiply the quotient of the denominator or rationalize. So let's have square root of 5 plus this one multiplied square root of 1 times square root of 5 is just simply square root of 5, and then square root of 5 or 5 times 5 is equals to square root of 25. So that's why your answer is 5 or square root of 5 plus square root of 5 over 5. So where did you get the 5? It is the square root of 25. So now since we don't have any radicals on the denominator, I just have there is this one. Denominator, we can now do the operation. So I will rewrite it here. Square root of 5 plus square root of 5 over 5. So square root of 5 over 5, that one, you can just simply rewrite that one, this one, and or this can be written as 1/5 square root of 5. So there is a 1 as a numerical coefficient of these radical expressions. It means there is 1/5. And then this expression, there is a 1 numerical coefficient. So it means you have to add 1 plus 1/5. Then just simply copy square root of 5 because they are now having like terms or like radicals. So now adding this 1 plus 1 over 5, that's equals to 6 over 5 square root of 5. That's That's your answer. So if that's the case, if your expression is having just like this one, just like our example, square root of 5 plus the square root of 1 over 5, always get first the square root, or this one, write this one as square root of 1 over square root of 5. Get first the square root of the numerator and denominator, then rationalize to get rid of the radical sign, and then do the operations. So always consider if there is a denominator there, just like this one, always consider that there is a numerical coefficient beside the radicals. So it means it is just like this one. Square root of 5 over 5, that is equals to 1 over 5 square root of 5. So that's how we're going to add and subtract our radicals. So later, or in the next video, I will be filming all about multiplying and dividing the radicals. So that's all. I will see you on the next one.